Okay, class, let's get started here. Chapter 5 for the third time since we're starting the recording here. Chapter 6, guys. I'm going to talk about chapter 6 first. Chapter 6 is about solving equations. So remember solving equations a long time ago in Algebra 2?
Yeah.
It's like that. Uh-huh. So, not simultaneously, just one equation. We're going to know it's just some equation. Yeah.
All things change.
We're going to do that in chapter 6. But before we get there, we got to do chapter 5, which is we're going to learn a whole bunch of different identities. We've learned some already. But we're going to learn a whole bunch. We're going to take a whole chapter just to learn identities. We're good?
Wow. How many sections does this
Yeah,
chapter?
there's probably five sections for chapter 5. Cool. So then, with chapter 5, I need you guys to remind me of, do you guys remember any of something called the reciprocal identities?
Yes.
Reciprocal. Okay, so you guys talk to me here, name them, and we'll go with yes or no.
Oh, those.
Reciprocal were the ones that something about like sine and cosecant relationship. Is that right? So perfect. Okay, so let's go with that one here. So let me do it the way the book does it in this. So cosecant. I'm gonna use theta. I could use x. I could use the other. Sine and cosecant have an inverse relationship. So if you see cosecant, you can change it into 1 over sine. Also, if you see sine, you can change it into 1 over cosecant. But mostly what we're going to do is we're going to change things into sine and cosine and sometimes tangent. Hardly ever, but sometimes. Okay, next one on the list. What is the reciprocal of cosine? The secant. Secant is the reciprocal of cosine. And then we have 1 over, oh, sorry, just kidding. How about cosine, right? It would be the reciprocal of secant. And then one last one for these guys. Cotangent, reciprocal of tangent. That was an easy one. And that means the other way around goes the same way here. So tangent is the reciprocal of cotangent. Okay, got those. Those were, I think they were called the basic identities, weren't they?
Check.
5.1. Thank you so much. Oof, okay. So this is section 1, so 5.1. Thank you, Kevin. This is called proving identities. There it is. Now the notes are correct. Okay, let's see. We got those. Tell me if I'm going too fast as well. Cool. All right. Then we have something called, let's see, we got the reciprocal identities. Oh, yeah, that's right. We have the ratio identities. You guys remember the ratio identities? There's only 2.
Oh, sine over cosine.
Perfect. Yeah, tangent is equal to sine over cosine. We are going to do some proofs here today. And then the other ratio identity, if you guys remember from previous classes, like chapter 2.
Yeah. So echo and it is a little sinus.
I'll go with that here. Just a flip of the one that was right over here. So tangent is sine over cosine, but cotangent is going to be cosine over sine. Okay, we got that one. That's cool. Boom, boom, boom. And then the last type.
Intellectus.
That goal. Make sure I spell it correctly. 3N identities. Do you guys remember those? We only did one. I think we only did one, did we?
Yes.
Remember we used
Cosine squared plus 1 equals. This is squared in the square roots, but I don't want to mean.
I'd go with that here. I think it's this one. It was the sine squared plus cosine squared equals 1. Okay, we're going to start with this one here, right here first. So did we ever write this in a different form? Perfect. Yeah. So what we can do is we can take this guy, we move it over here. Well, it says this one, we can write this like this. So sine squared theta is equal to 1 minus cosine squared theta. Cool, cool. All right, what's another way of writing this? Perfect, Cosine squared theta is equal to 1 minus sine squared theta. That's good enough there. Is there another way of writing this? Perfect. Yes. Okay. I have to move on to the next. No, actually, let me do this here. Let me see if I can put this on a different slide. The power of PowerPoint. It's in the name. Okay, so how about this one? We are going to take a square root of this guy here. And look at that, we can get back to a linear function. We're going to say sine is actually equal to the plus or minus the square root of 1 minus cosine squared theta. Okay, I think we did that one before. Did we do that one before? Okay, and then this one right here, this would be cosine. So, phew, anybody count this for us? How many different identities have we got so far today? If we start counting each of the identities we've covered.
Wait, identities being like classes of identities?
So every single one that we've got so far.
13?
Got 13 identities so far. We good? Whew. Okay, let's go some more. Now this one, I'm not sure. You guys tell me yes or no if we covered this already. Got a few people still writing it down, so go for it. All right, and clicking on this guy, let's do this. And tell me if we did this before. Let's look at sine squared plus cosine squared equals 1. Have we tried to form other identities based upon this guy? Sweet. Okay, so I got this little guy. Anybody need to go back to the previous slide? What was the trick that we used to find even more identities? You can change the interpretation models. Yes. It's this one. It's like a little trick that we like, oh, remember, who was it? I think it was, what's the guy's name? Ptolemy sitting on a Saturday morning. Is that right? Had nothing else to do. No, no. No, no. That is, well, there's like, it was one little trick. Ptolemy sitting Saturday morning, had nothing else to do, and he says, you know what? I wonder if I can divide by one of those trig functions. I wonder if what I get out of it. And oh man, perfect. Okay, here it is. So he just decides one day, how about if we do this? Can I make even more identities based upon this? I'm just going to divide everything through by sine squared theta. And if I do that, I think I got myself a whole new class of identities. Now the connection is between 1 plus, oh, we just covered this here. What is cosine over sine? Cotangent. I got a cotangent relationship now. Now, don't forget it's squared, right? Because you have two cosines on top, cosines on the bottom. And we got ourselves this guy, 1 over sine, or 1 over sine squared now. Cosecant squared. Okay. Perfecto. Okay, that's another identity. Now the question is this: can I turn this around any which way to make any more connections between here?
Yes. You secant for data minus the tangent, so data equals 1.
Perfect. Okay, so we're just gonna list all the different things that flow out of this relationship. We good? So if we move This one over here, we can say 1. If we subtract it over here, can I just write it like this, I guess? Cosecant, right? Cosecant squared theta minus cotangent squared theta is equal to 1. Is that okay right there? Oh, that's weird. It's kind of like the sine cosine relationship, right? But a minus instead of a plus. Interesting. Okay. So then the question is this. Oh, how about this? How about this top one? Can I just take a square root of it? Yeah, so then I go like this. I go cosecant theta is equal to plus or minus the square root of 1 plus cotangent theta. Okay, got 1, 2 out of it. Any others I can get out of it here? So we're just trying to get any which ones we can get here. Should scoot this over though.
What about cosecant minus 1 equals cotangent squared?
Cosecant.
Cosecant squared theta minus.
Yeah, let's do it this way here. Let's do cotangent squared theta is equal to, we move the 1 over this time, is now cosecant squared theta minus 1. Oh, you know what I can do? I can do the square root as well, right? Can I do the square root of this one here? Now this is going to be cotangent theta is equal to the plus or minus square root of cosecant squared theta minus 1. Boom. Whew, that's a lot of, is that all the different relationships we can have? 1, 2, 3, 4, 5. If I go back real quick here to this one, notice we got 1, 2, 3, 4, 5. Okay, that sounds about good. We good? So now we're up to, let's see, 13 plus 5 more is now 18. We've got 18 different identities. Stop there, slow down a little bit. If you guys need this slide here. Okay, so Ptolemy, again, sitting Saturday morning, nothing else to do. You guys talk to me. Are we good there with those identities? We're just kind of moving things around the equal sign, that's all. Yeah, and make sure you write them down correctly here, because if you don't, then you look back at your notes and you're always going to get them incorrect there. Okay, we don't use these we don't use these a lot, right? I think there's like one problem in the homework you're going to use, I think, this relationship right here, that you're going to have to sort of get stuff out, or this relationship here. So not quite often. The previous ones are the ones, previous slides are the ones we use quite a bit. Okay, yeah. Still doing good. So then Ptolemy, oh, nope, don't want to do that. Sitting on a Saturday morning, says, you know what, that's fine. I got this relationship here, and I just divided everything through by sine squared. But I wonder, there you go. I wonder if I can just divide this guy by cosine squared. And I wonder what comes out of that relationship. Yeah, divisions or something like that. Yeah. So these guys are all connected any which way. So I got myself, oh, what is sine over cosine? That's a 1 and 1 over cosine. Perfect. Okay, this one we're going to use a little bit more than the previous slide. That one comes up a little bit more times just because tangent has such a unique relationship with when we model stuff. Okay, so I got this one. Now I need 4 more variations of this guy. Anybody start off with 4 more variations here? Sorry, say again. Tangent. Okay, perfect. Yeah, let's move the 1 over. So this is going to be tangent squared theta is equal to secant squared theta minus 1. Aha, and I like this one here. We just take the square root of this guy here, right? Take a square root, gets plus or minus the square root of secant squared theta minus 1. Oh, hold on. If you go back to the original one that we just made, can I just take a square root of this guy? So it's going to be the square root of this guy kind of flipped over. So this would be secant theta is equal to plus or minus the square root of tangent squared theta plus 1. Okay, da-da-da. I think okay. Bless you. All right, I'm missing one more here. I don't know which one it is. What is the one that I'm missing? Oof, I don't think so.
So you can minus three squared theta.
Because yeah, if we move the tangent over this way, right? We get ourselves secant squared theta plus tangent squared theta is equal to an, oh, that's now a positive relationship. Remember how we had sine squared theta, right? Plus cosine squared theta equals 1. When we move to cosecant and cotangent, it was a minus relationship. And this is a plus relationship. Okay, 1, 2, 3, 4, 5. Are we good?
Why, how is it positive? Wants to be a negative, right?
Just checking. Just checking if we're all paying attention. Is this a minus sign right here? There you go. All right. So sine squared theta plus cosine squared theta is the only positive relationship, right? To equal 1. And these other two, they are going to be negative relationships to give you a 1. Okay, are we good there? So this is crazy. I think it's a little crazy. I'm going to side venture here, right? If you write the number 1 just by itself, just like sitting there, just 1, right? What this means is, this means that this is the exact same thing as, right? Isn't that what equal sign means? Isn't that crazy? That's what it means. 1 is equal to that.
One
Right?
equals to
Yeah, and all the other ones, right? Yeah, the secant. Is it secant squared?
yes.
What else? You don't need to copy this down. I just kind of think it's kind of crazy the fact that cosecant. Okay. So to confuse your younger siblings, you can always do that, right? Like when they write a 1, you tell, oh no, you know what's the same? It's the same as
You
this.
tell them numbers.
Just mess with them. Uh-huh. Just mess with them.
They
Hmm. Okay. Let's go with exercise now. So then we have 23 identities. Is that right? Boom. Okay, we're going to use these now. We've done this before, but we're going to just use to prove that we have more identities or these identities are the same. So let's go with it. Exercise 1, prove that each of the following identities are true. So prove that each of the following identities are true. And let me just check something as we go here. Okay. Start off easy. And so here's a rule of thumb is that if you can, just change everything into sines and cosines and see if things work out nice. So this is a crazy thing here. Notice what it's saying is that is also an identity. Are we good? We don't use this identity much, therefore it's more like an exercise problem. But technically, sine times cotangent is equal to cosine as well. Are we good? Okay, so what do we do here? 99.5% of the time, we change everything to sines and cosines.
Yeah.
That 0.5% of the time, sometimes we'll change it to tangent. Very, very rarely, just to make it easy on ourselves. But let's go with it here. Notice real quick here, we are proving an identity. We're not solving an equation. We're good? So we're not trying to move anything to the side. We're just trying to make sure the right side and left side are exactly the same eventually. So sine is already sine, no need for that. Cotangent, can you guys convert cotangent as sines and cosines? I'll go with that. Cosine over sine. And this guy here can stay the same. We don't need it. The only thing is I'd like to put an equal sign as we go down. And then I got myself something that looks like this. Is that right? Sine is the same thing as sine over 1. And what gets to cancel?
It's fine.
Signs are gone. We have now proved that the left side and the right side are exactly the same. And what do we put at the end? Absolutely. QED, if you want to be Latin-ish. If you just say like, I'm done. Okay. Did you guys talk about it in your Latin class? Did you guys tell Dr. Blythe about it? You know, that'd be kind of fun to.
So she was off.
Oh, and then also, we have, don't we have like Latin in today's world and stuff like that? I figured this should go on the board there if it's not there already. Right. Okay. Is it going to get more difficult? Of course it's going to get more difficult. And B. Just a little bit more difficult here. Tangent. I'm gonna use X. I can use theta. It doesn't matter. Either one's fine. I'm gonna say this. Oh, you know what? Let me actually get a little bit more difficult because you guys are cool like that. Just I'm gonna. You got so on. Okay, I'm gonna move this over and then just some more space. How about this? Ooh, now we got ourselves some. Yes, same thing. Oh, never mind. What the heck?
It's a little bit ahead of you right now.
Okay, how about this one? Da 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 da.
So close.
Change it all into forms of sine plus.
Yeah, the only thing is I want to do is first is since we have parentheses there, I probably want to just multiply this out to here. See, just one and here, just because of that multiplication there. So I'm going to leave it just the same in just a second here. So I'm going to go like this. Just this whole concept of distributing the sine of x. Now I got myself sine of x multiplying secant of x plus sine of x multiplying cotangent of x. Okay. So let's see what we got. Okay, yeah. Tangent is sine over cosine. There's that one. And cosine is just cosine, so that's cool there. This guy's going to be sine of x, and this is 1 over cosine. And this is sine and cotangent. Cotangent is cosine over sine. True, true, true. Okay, so the right side, sorry, the left side, that's about as simple as we can get, right? There's some things we got to do on the right side, though. Sorry,
On
the left side is pretty simple, right?
so sine x, what times cosine x over sine x, the signs cancel.
Perfecto. And here the signs cancel, and we're left with cosine, and do we have the same exact thing on both sides?
No.
I got the exact same thing on both sides. Is that right? I got sine of x over cosine over there and there. Plus sine. I got cosine, cosine. I'm just done.
Watch them obviously. We'll stop at like episode before the last episode for season 1 point. Where's the Bible? And I'm saying this did.
And pay attention.
Yeah, I understand. Okay, you ready for C? Let's go with it. And I'll let you guys try it yourself. You turn to the person next to you once you've done it, just to see if they have got the same thing. I will also say this. Let's see. G of x multiplying. Is it multiplying? Yeah, I think it's multiple. Multiplying cotangent squared x plus 1 is actually equal to 1. All that should go away.
Oh, you don't.
What the heck?
Oh.
It's wild.
It's either, I think it's better than that.
Based upon what we just learned from about C, Sorry, about B, what should we do first? Probably distribute the secant squared x to both sides and then see what happens. All right, for honor students, though, you guys will graph stuff on your calculator. Because sometimes when you look at identities, sometimes what we do is we graph them to see if they form the exact same curves. And if they are identities. And if they're not, they are not identities.
Wait. You don't have to. You can just make it like the secant and the. You know, you know what I'm. Wait,
I don't know.
I forgot the squared. That's important.
I do not know.
Give me a second.
Uh-huh.
You and your brother know the same one. Yeah. What? Just. I like just like the same. We have the same kind. I might be wrong. I might be wrong. You're right. It's like a bad thing. You just. But I'm thinking. Yeah. Yeah.
Are we good? Good. So I'm going to distribute the secant squared first. Is that right? So I go here. And I go here. Anybody got the answer yet?
Yeah, but then you can like.
I know. Yeah.
Let's see. 1 times cosecant squared. It's just going to be cosecant squared, right? And then I don't need to put the 1 down because we already know the one's there. So let's see what we got here.
Okay, awesome.
One second. 1 second.
Wait.
Stop. I could have messed up. 1 second here.
Only gives us like.
You get it.
They're like 45 here.
That sounds like so much fun.
That's right.
Class, I'm so sorry. 1 second. I have this one marked off my notes. The thing is because it did not work. It is not an identity.
Oh.
Sorry. Now that I see it, like, why did I have a line through the whole entire problem? Sorry, guys, this is nuts.
I got
I gotta say, I got to 1 over sine squared plus 1 over cosine squared equals 1. Not like that.
Yes, yeah. That's not always, yeah, sorry, class, C is not an identity. That was messed up. Let's go to D. Let's do one that's actually is an identity. Yeah. So this one, yes, this one is an identity this time. I was being a little bit, and sorry, guys. Okay, now try this one yourself. Very similar to the one we just did. Let you guys try this one. This one is going to work out now.
Cotangent is squared, then is it cosine squared over sine squared? Yes, because it's cosine squared over sine.
Yeah. So you got to distribute the sine squared first. There.
Oh, done. Oh, that's much easier.
Yeah, that's what I was trying to go in there after not having to go. Instead of your much well. And she said, no, we're gonna do.
Yeah, because that's my that's Pythagorean.
Adorable. It's like.
I feel I left it.
Oh, yeah.
We didn't even get the answers.
The sweetest.
All body weight stuff.
That wasn't better. That one wasn't hard because it was real.
It wasn't crazy. Yeah, so let me do this here, see if this is the same thing that you guys did here. So I got this. times this. Whoop, sorry, not that yet. Cotangent squared out. And then as you multiply sine times sine squared times 1, you still get sine squared. See if I can spell correctly. Now I don't need to put the 1 down if you like. That's fine. And then from here, I got myself sine squared x is equal to cosine over sine. And I think I know what happens there. Sometimes what happens, guys, you guys will go down kind of like a rabbit trail. Like, whoa, this is working. This is not working. And then eventually it does work out anyways here. So, is that. And then this right here, oh, I do have to go to the end. I do have to say that 1 is equal to 1. We're good? Because we want to make sure that we have the right side is exactly the same thing as the left.
Watched Syncopated.
Then one with one, can I also say that one is sine squared x and sine squared x, and then have it be cosine squared x, sine squared x equals cosine squared x.
Perfect. And real quick, Caitlin's asking, can you just say 1 is the cosine squared x plus sine squared x? Yes. As long as the one side is equal to the other.
First time I've ever heard
All right.
something and just not processed it at all. It was like just straight through. Probably not the first time, but the first time I've been cognizant of it.
That is
You
so
just
funny.
spoke and it went straight through my head, and I did not understand it.
Most fun thing.
So,
I don't talk really fast, so I tend to, like, I process information like.
all right.
Yeah.
Faster than
Like
I.
we were talking about the history, yada yada. Yada,
Let's see.
yada.
Oh, my God.
Super difficult or medium difficult? What do you guys say?
Super duper.
I heard medium first.
Oh.
I'm gonna go medium. Here we go. Tangent. Again, by yourself. By yourself, then after you're done, then see if you can turn to the person next to you to see if they got the same. Theta is so much better.
Yeah. You were on it.
Okay, so this is interesting. One is going to be an addition between the two, and one is a multiplication between the two. How do you change addition to multiplication? Still be the same? That's too crazy. All right, go for it, guys. Yourself. Let me walk around and see how you guys are doing.
Wait.
Try this one yourself. This is a little bit more difficult one.
You do the one side, do the other. Focus over some.
And as you make things simpler and simpler and simpler, you should be able to sort of see, oh, that's what I need to do to connect.
Wait. Oh,
I don't know if this is the
last one we did, so like, you divide sine, sine squared x, both sides, but like, doesn't that also, it makes it one. But,
This one
was kept as in line.
well, I kept on there, the last one.
Yeah, right, so it was a. Okay, so then just a quick show of hands. Ta-da. Oh, good. Some, we've converted that into a rule.
Did you get it?
Yes.
Oh, hold on. We can hold that.
You multiply by cosine and
Yeah, now I'm also.
you multiply by the side.
Mhm.
Did I do it right?
Wait, you, okay.
I wasn't sure about one part.
You do.
Did you multiply like both sides of the equal sign by cosine?
Oh, okay. What is it?
Yeah, we can't do that.
Why can't I do that?
What?
I did the same thing. Why can't you do that?
So this cannot move across the equal sign, right? So the left side, you just simplify, the right side you simplify. You
Oh,
can't
okay.
multiply something on both sides of the equal sign. Right? Because you're not solving equations, right?
Okay. So I did it separately and then they ended up being the same thing. How about that?
Yeah, can I,
Oh,
can I do the same thing on both sides? Like just.
Still same sides.
I don't know if I did it wrong anymore.
Just for the fun of it, you can't multiply both sides by cosine. Can't do that. You're not solving equations, you're proving.
Okay, wait.
Multiply each side by cosine individual.
What is?
One's plus.
I feel like you make.
Okay, just really see certain things here, ready? I see some people forgetting the x or the theta. It doesn't matter if you want to stick with theta all the time, that's cool.
Oh.
But I can't,
He's stumped.
if you have this, right? And you do have to go like this, and you, I'm not pointing you out, Megan. I'm not pointing you out at all. Okay, so you do have to have the theta after, right? It's a trig function of an angle, right?
No problem, like, the data.
At the end, I guess you can technically do that.
That's how we get to not. We try to add the.
Yep, so the,
I'm having some. I didn't look about it. Next thing. Well, I'm saying, there's some people who visit the slow was like getting it next year. Why not? This is so easy.
Fine. All right, I think most people are done here. Let me go to the answer. Let's see if you guys got this. Okay, everybody got to this point, hopefully. And then this is, you can do the 1 over all that, or you can do one individually, right? So your secant is 1 over cosine. And this is 1 over sine. Everybody okay there so far? And then on the left-hand side, we need to have some common denominators. That's what we need to do. So notice I'm not multiplying across the equal sign. I'm just multiplying to each individual fraction here. So this guy here, in order to get common denominators, I guess I could write like this, right? I could write like this. That's the way we would normally process common denominators. I need a cosine. And then I also need a sine here. I need a cosine. Then I also need a sine over here as well. Are we good there so far? So then the question is, if I'm going to get this new common denominator, what should I multiply the top by? I need to multiply the top by sine of x, which gives me sine squared x. If I go over here, what should I multiply to get common denominators? Cosine. This was a little bit more involved, huh?
Wait,
Okay, I got that right there.
medium.
This is medium difficult.
Wait, and then you have on the other side 1 over cosine sine.
Okay, on this
Can
one
that
I
just-
have 1 over cosine, and Adrian asked the question, go.
Can you just make it sine squared theta plus cosine squared theta equals 1? Like, does that work at that point or no?
On this side, yeah, on the right side, yeah. So this guy here, as you put common denominators together, can you, let's see,
Cancel them out.
on the, over the top, it would be sine squared theta of x, right? Cosine squared x over, just kidding here, x, sine of x, and I'm running out of room. I gotta do the next slide. Good there?
That's how, because you don't.
All right, we good there? And then the last part. The last part is you're gonna do this. Here, you're gonna put 1 over cosine of x, sine of x. And you're gonna have to bring down the right-hand side so that you have the exact same thing on both sides. And once you have the exact same thing on both sides, you write UED, boom, boom, boom. Super hard one. Doo-doo-doo.
It's too late now.
Now, we have F. F is 1 plus sine of x over cosine of x. I think so. Equal to cosine of x over 1 minus sine of x. What? That's crazy.
Isn't it easy or hard?
That's the difficult one. Difficult.
One.
Are we already in time in terms of cosine and sine?
Yes.
Yes, we are. Oh, brother. So we can't simplify this, right? So here's the trick. No, because they're on either side of the equal sign, and you can't touch both sides of the equal sign.
Wait, can't multiply.
You can't multiply like you can't multiply cosine on one side and cosine on the other, right? We do that in algebra in order to solve equations, right? But not here.
Absolutely, and it doesn't work in the bathroom setting. Oh, great. You just all just start in the middle, like feed it like I'm going in the middle. Like, how do you?
All right, this is the stuck part. So here it is. We're in terms of cosine and sine as well, right? So here's the little trick. The trick is this. Notice on the bottom, guys, real quick here. Notice on the bottom we have a cosine, and they have also we have fractions here, right?
Oh,
So I'm thinking this. I'm thinking if I can get a cosine on the bottom over here, we good? Would that solve my problem?
Yeah.
So here's what we're gonna do. We're gonna keep this side exactly the same, no change to this side whatsoever. But what I'm gonna do, I'm gonna keep this side like this, and I'm gonna multiply. I'm not multiplying across the equal sign. I'm just multiplying one side of the equal sign. I'm gonna multiply this guy by cosine of x and a cosine of x. Now, in math,
Got the squares, which would make it an identity, which would make
ooh,
it.
you're like 3 steps ahead of me. Yeah. What I wanted to do is I just wanted to have a cosine on the bottom of my fraction. I wanted this denominator here to connect with this denominator here, right?
you just do cosine.
So then I have, oh, okay, real quick here. In mathematics, what allows me to multiply something by cosine of x and a cosine of x? Cosine of x on top and a cosine of x on the bottom. What am I technically multiplying by? By 1. I'm not changing anything, right? So now we're good. I think we're good now. So on top I have cosine squared x. On the bottom I have a 1 minus sine of x in parentheses. And you can put this one in parentheses if you like, or you can just kind of leave it outside. So now what I see is I have some connection. Now I have the denominator that I want, right?
Multiply the other side by 1 minus it.
Ooh. Wow.
Over 1 minus it.
I can't multiply. You could, but I'm thinking go a little bit different. Do we have an identity connected with a cosine squared x? That gets you back into something that has to do with sine.
Yes. Squared x plus cosine squared x equals 1.
Yes, but I need the connection between cosine squared of x is equal to
Who goes 1 minus sine squared x?
1 minus sine squared x. We good? That's what the top equals. And then, oh boy, almost there. Anybody know
It's gonna become tangent.
what is going to become tangent?
The whole thing. Like sine of
Uh-uh.
no?
I have a 1 minus sine squared x, and then I have a 1 minus sine. I somehow have to get rid of this. Is that right?
Okay, separate.
Oh, okay. Yeah, so real quick here, can you guys separate this out? Does that look like something familiar from algebra? Kind of like 1 minus x squared. Don't usually see it like that. We usually see it as x squared minus 1, right? X squared minus 1 will factor down into x minus 1, x plus 1. Okay, hold on then real quick here. What is 1 minus x squared going to factor down into? No. 1 minus x squared is going to factor down into 1 minus x, right? And 1 plus x. Okay, so then we go over here. 1 minus sine squared x is going to factor into of x and
plus.
perfecto. Okay, so then, whoa, it went off the grid rails here.
1 minus sine x.
Perfecto. Uh-huh. So I got this over this. Sorry, guys, I have to rewrite it on the next slide. Didn't have enough space. Now I'm with, I have this now. 1 minus sine squared x, is that right? 1 plus sine squared x. Oh, is it? Not squared, yep. 1 minus sine of x. multiplied by cosine. And now do I have the same thing on both sides? Perfect. Okay. Was that a difficult one? Yep.
What would have happened if after we multiplied the right side by cosine over cosine? What if you multiplied the left side by one minus sine x over one in the sine x?
Works. Huh? So you're still gonna have to use identities in order to get to cosine. You'll be canceling a cosine squared on the left.
Okay.
Perfecto. Okay. Sweet. Okay, and then let's see. Uno más. Uno más. Yep. All right, and these guys also get longer and longer.
Right.
Okay, and then a difficult one, another difficult one. Ready? F. So this is G. G starts off like this. So the difficult one seems to be the fact that we have to factor stuff down. Oh, and then I'm going to introduce another variable called T.
Sine squared?
No, what is cosine to the fourth? What?
You can listen.
This is very.
What?
Hard.
Lost my train of thought.
Does the team matter?
So theta, X, T, any one of those is fine. So let's do this one here. You can go different directions. But first things first is cosine to the fourth t minus sine to the fourth t. Is that factorable?
Yeah.
So you go over here. Let me give you an example from algebra. What did you guys do in algebra when you had x to the fourth minus y to the fourth? What did that factor down into?
I don't remember squaring.
Oh, gotcha. Okay. So it is just like x squared minus y squared, except because there's a fourth, what you have is you have this x squared plus y squared. And, oops, x squared minus x squared. All you do is the minus y squared. Yep, there it is. Oh, good.
Okay.
So anything to the higher powers, all it is just the lower powers and squared.
That makes.
Cool. So on top over here, running out of room already. Now I have a cosine squared t plus sine squared t, another parenthesis, cosine squared t minus sine squared t. All over cosine squared t, which is still equal to all that right there, which I don't even want to mess with that just yet.
Not the route that I took.
Oh yeah?
I
Ouch.
didn't finish it.
Ooh, okay, yes. So let's talk about that.
Sorry.
Now 1 times 1, but Kaylin is getting to something here. Class, what is cosine squared t plus sine squared t? That's a 1. The only thing is, that's not a 1, right? It has to have a plus sign. So now we have ourselves cosine squared t minus sine squared t all over cosine. Now, real quick here. Ooh, no.
Okay, no, I'm one.
Because it is held together by a minus. You can't cancel fractions because they're a different order, right? With pluses and minuses, because a fraction is a multiply divide. Hey, just real quick here though. I can also divide cosine into cosine and cosine into sine. Is that okay? Can I do this? I'm gonna.
What?
I'm gonna split this off into that divided by this and this divided by this. Is that okay? Can I split fractions? So if I have like 1 plus 2 divided by 5, right? Isn't that the same thing as 1 over 5 plus 2 over 5? And if that's the case, cosine squared over cosine squared is 1. And what's sine squared over cosine squared? Tangent squared. That is so cool.
Oh. No, it's not like canceled out like that. Like sine squared theta over cosine squared theta equals tangent squared.
So, Kara, say that one more time.
Don't like you can change. Like. You don't have to have them in not squared forms to use the. Reciprocal ones. Like, if you flip it. Oh, yeah, because it doesn't matter. Because it just is to a higher.
It's really cool. I have a question.
Yes, yes.
I understand how you did it. I was working through this. And I have.
Yep.
Also, skip picture. Cosine squared minus sine 4 equals.
So the fourth over.
If there's something.
Oh, you factored it already. Okay, gotcha. Okay.
And I got this. Right?
Uh-huh.
And I have this. And I was wondering if you could subtract each.
I am
But like, how would you? Did I mess up somehow?
What?
Is it just not a valid way to do that?
It's just not, I don't think it's the correct factoring form. Let's see. You did, right here, you did this? Yeah.
No.
Let me, I don't think so. I think you factored wrong, but that's sweet. Hey, class, real quick here before we leave. First things first is, for chapter 5, on the back of the book, it actually says this. It says answers vary. Because you can take different directions to get to that. So there is no answers for 5.1.
Oh.
So what I'm going to do, because you can go and the process varies, right? So I'm going to send you guys the answers to 5.1. Now, when you guys send me the answers, they don't do this. They don't do the structure where the right side and left side match. What they do is they start it with one side and they make it go to the other. Are we good? So just try your hand at it. If you go down a rabbit hole, stop, go back to the beginning, but the rule is 5.1 is due Wednesday.
No.
Actually, no. Okay, let's see. We didn't finish one little aspect of 5.1, but that's okay. I'll do it off the home. Yeah, we're good. Yeah. So yeah, we can do Wednesday. Thanks, guys. Enjoy the rest of your day and weekend and everything else. Uh-huh.